Hi guys, welcome back to Algebra 2. Today we're talking about 2.7, example 1, which is maximum and minimum values for a bounded region. So what we're going to have here is we're going to have a system of linear inequalities. So that's going to be the first three things here. And we're also going to have our function, so f of x and y. So this is going to be a little bit different. We're putting like two or three things together here. To find out what the maximum or minimum value is for your bounded region. So the first things that we want to do is graph the system of inequalities, name the coordinates of the vertices of the feasible region, find the maximum and minimum values of the function for this region. So step one is to graph all of these functions. So the first thing that we're going to do is graph the inequality x is greater than or equal to -2, or x is less than or equal to 4. So if you look here, we have solid boundaries at x equals -2. It's right here. And x equals 4. And since it's x is less than 4 and greater than -2, we're going to shade in between the lines here. We're going to go ahead and do the same idea with the next inequality, which is y is less than or equal to x plus 2. It has a solid boundary because it's equal to, and is shaded below because it's less than. So we look at this line and we go down, shaded below. The overlap of -2 is less than or equal to x, and x is less than or equal to 4, and y is less than or equal to x plus 2 is the darker shaded region. So if you look right here, the darkest shaded region, so in between the two vertical lines and below y plus 2 or x plus 2 is right here in the middle. That's the next region. We have one more, and it's the inequality y is greater than or equal to -0.5x minus 3, and it has a solid boundary at y equals -0.5x minus 3, and is shaded above since it's greater than. So if we look at this line right here, the new one that's graphed, we're graphing above it. The feasible region is the overlap of all three inequalities and is the darkest shaded region. So we have our boundary from here straight down and over here. So the darkest region here is the feasible region. And then we're going to take the vertices. So what a vertex is like a corner or a point. Right here, it's all of our intersections. So where things are intersecting. So we have four different intersections. We have 4, 6 at the top. If we go straight down, we have 4, -5. We have -2, -2, and we have -2, 0. Now, what we want to do with these vertices is we're going to plug them back into our f of x and y function, which is -2x plus 6y. So we're going to do this 4 different times, but with these x and y values of each one of our vertices. So when we evaluate the function, these are on the left column, we have a list of our vertices that we got. The middle column is our function, f of x and y. So we have -2x plus 6y. What we're going to do here is just plug in our x's and our y's into each one of these functions. So for the first one, or the first row, we have -2, so that's the coefficient here, times -2, which is our x value in the first one, plus 6 times -2, and we get +4 minus 12, which is -8. For the next one, our x value is -2 and our y value is 0. So we're going to substitute those in, same idea. We're going to get -2 times -2 is +4, plus 0, so we're going to get 4. Our third row down, we got 4, -5. Our 4 is our x value, -5 is our y value. So we're going to get -8 minus 30, which is negative 38. And 4 comma 6 is our very last one. We're going to get negative 2 times 4 plus 36, which is 28. Now, if we're going to find our minimum and our maximum value, all we're going to do is take the highest number that we get after we evaluate our function, which is going to be 28, and our lowest one, which is going to be negative 38. So when you write this, you want to write it as the maximum value is 28 at 4 comma 6. The minimum value is negative 38 at 4 comma 5, and then we're done. Thanks, guys. See you next video.